These are notes for dilations and scale factors. Let's start by doing some definitions. So our first definition is going to be, what is a dilation? So what is a dilation? A dilation stretches or shrinks the original figure. So a dilation stretches or shrinks the original figure. All the segment lengths on the figure are multiplied by a number, and it's the same number. So all the segment lengths, so all the lengths of the sides are multiplied by a number. And that number is called the scale factor. Now let's underline that because that's important. Alright, so and then after the dilation takes place, you're going to end up with two shapes that are what are called similar to each other. So the resulting image is going to be similar to the original. So the resulting image is similar to the original. Okay, our next definition is going to be scale factor. We talked a little bit about it in our first definition, but let's kind of explain it a little bit more. So a scale factor is just a number. So it's some number that's used to multiply with. So it's a number used, and it's used for dilations. So it's used to dilate a shape. And a lot of times they'll use an R to represent it. So sometimes it's represented by an R, just a capital R. So if you see, for example, if you see this, R is equal to 2, that's your scale factor. Your scale factor is going to be a 2. And that's what you would multiply the side lengths by. Okay, so some properties of scale factors. It's always going to be greater than 0. If you had a scale factor of 0, it would just disappear the object. So it's always going to be greater than 0. And then if it's less than 1, you're going to shrink the object. So that makes it shrink. If it's greater than 1, it's going to get bigger. And that's called a stretch. And of course, if it's 1, it's not going to change at all. Okay, let's do some examples. Alright, let's do a dilation. So we're going to dilate the triangle that I'm going to draw in a minute. So we're going to dilate the triangle using our scale factor r is equal to 2. Alright, so here's our starting triangle. It has 5, 6, and 7 for side lengths. Okay, so we're going to end up with a bigger triangle. And each of the side lengths are going to be multiplied by 2. So our first side over here is going to be 5 times 2. It's going to be 10. And then over here we have 6 times 2, which is 12. And then down here we have 7 times 2, which is 14. So we end up with a triangle with the side lengths 10, 12, and 14. Everything's doubled, except the area. The area is going to change a little bit differently, but we'll get into that on a different lesson. Okay, for our next example, we're going to dilate the rectangle using a scale factor of 1/3. So that's less than 1, so I know it's going to be a shrink for this one. It's going to get smaller. We're going to end up with a smaller rectangle. And we just do it the same way we did the other one. We're still multiplying. You always want to multiply. So we're going to do 27 times 1/3, which is going to be 27 over 3, which is 9. So this top side is going to be 9. And you kind of think about it, try to go the other way. Is 9 times 3 27? Yes, it is, and it works. Okay, so do the same thing for the other side. 18 times 1/3 is 18 over 3, which is 6. Alright, on this next example, we're doing a kind of a different type of scale factor, a different format for it. Instead of doing just a straight fraction, we have a ratio now. So it says the scale factor from A to B is 2 to 1. So we're starting at A is a 2 and B is a 1. Okay, so the way you do this is you just make it into a fraction and then multiply just like we did the other one. The thing is, the result needs to be the top of the fraction. So we're starting from A, we're going to B. So the top of the fraction is going to be a 1 in the numerator, and then the denominator is going to be a 2. So this is our scale factor, it's 1/2. So then it's easy to figure out the missing side. We just do 12 times 1/2, which is 6. Okay, this one's a little harder. We're going from A to B, and the scale factor from A to B is 4 to 5. So the A, since it's first here, it's first here also. So the A is 4, and then the B is 5. Okay, so I remember when we're doing scale factor, the result, the missing part, needs to go in the numerator. So we're going from A to B. So the B is going to be the 5, and then the A is a 4. So this is our scale factor as a fraction. It's 5 over 4. Okay, so then we want to take our 28, and we're going to do times 5 over 4. Okay, so we need to make it into a fraction. So we do 28 times 5 over 1 times 4, and that's going to equal 140 over 4, or 35. Okay, what about if we know the scale factor? So what if we know what if we know the sides but we don't know the scale factor? So what if we need to find the scale factor? Okay, so for example, let's say we had a rectangle right here, and it had sides of 30 and 40. And we're doing some kind of dilation. We don't know what kind it is. And we're going to get a result with the sides of 6 and 8. I want to find out what is the scale factor equal to. Okay, so first of all, I need to match up two sides. I need to make sure that I match them. So looking at my drawing, I have 30 and 40 and 6 and 8. The small number is going to go with the small number, and the large number is going to go with the large number. So the 30 is going to become a 6, and then the 40 is going to become an 8. I can use either one of those, or if you want to be sure that you're doing it right, check both of them. You should get the same answer using both. I'm going to do both. Alright, so remember, you're multiplying by the scale factor. So this is just a little bit of algebra. We're doing 30 times the scale factor, and we're getting 6. So we just have to divide, and we'll get 6 over 30, which simplifies into 1 over 5. So our scale factor is 1/5. Alright, let's try it with the 40 and the 8, make sure that we did it right. So we're going to do 40 times r is equal to 8. Divide both sides by 40. And 8 over 40 is also 1/5. You should get the same scale factor for all the sides. Okay, let's try one that's a little more difficult. On this one, we're starting with a rectangle with sides of 8 and 14. The result of the dilation is going to be a rectangle with sides of 12 and 21. So this is a stretch. Alright, so let's match up sides, make sure we get the right sides when we do this. The 8's a smaller one over here, and the 12's a smaller one over here. So we get 8 going with 12, and then 14 goes with 21. Okay, so let's set up. We can do either one. Let's do 8 and 12 just because they're smaller. Maybe it'll be a little easier. So we'll do 8 times r times our scale factor, and that's going to equal 12. We'll divide both sides by 8. And r is equal to 12 over 8, which when we simplify it is going to be, let's see, 4 goes into 12 3 times, 4 goes into 8 twice. So 3 over 2, or 1 1/2.